Let's discuss item 14. This is discussion of naturally occurring radioactive material as it relates to the Hickory Groundwater Supply project. Ricky Dixon, you're on, and be concise and precise, please.
Thank you, Mayor. I wanted to come back and talk about this one more time. We've done this before in the past, and there are new council members, so we wanted to go over it one more time and make sure. You know, I'm still hearing some issues and some concerns from the public and also from members of the council, so we're going to go another run at this. Today I have with me, that'll actually be doing the presentation, is Dr. Ian Hamilton and Mr. Rick Jacoby. Dr. Ian Hamilton received his Bachelor's of Science from the State University of New York and his Master of Science and PhD from Texas A&M University. Dr. Hamilton has 30 years of experience in nuclear engineering and medical and health physics, and is currently the Corporate Radiation Safety Officer for Scott & White Healthcare System. He is a board certified in the comprehensive practice of health physics and a licensed and board certified medical physicist. The U.S. Navy provided Dr. Hamilton start in radiation science and is a division leader on the ballistic missile sub USS Henry Clay. His experience includes a nuclear engineering professorship at Texas A&M, radiology professorship at Baylor College of Medicine, and committees concerning and consulting for nuclear and medical facilities. He has participated in several national level committees concerning counterterror and domestic preparedness even before 9/11, which culminated in several widespread reports and an annual teaching engagement at Harvard. He was appointed by Governors Bush and Perry to the Texas Radiation Advisory Board, of which he served several years as vice chair. He was the primary author of the Texas Radiation Advisory Board's 2011 position statement on radionuclides in drinking water. He also wrote the definitive peer-reviewed paper on the environmental impacts of radium pipe scale removal process in the oil and gas industry, published in the Health Physics Journal. He is a member of the American Association of Physicists in Medicine, American College of Radiology, and the national and local chapters of the Health Physics Society. Mr. Jacoby received his Bachelor's of Science and Master's of Engineering degrees from Texas A&M University. In addition to being a licensed nuclear engineer in Texas, Mr. Jacoby is a health physicist and licensed attorney in Texas. He has more than 39 years of experience in technical and regulatory assistance in the licensing, construction, operation, and decommissioning of nuclear and radiological facilities. This includes expert guidance on radiation risk assessments, licensing and permitting of nuclear facilities, environmental assessments, nuclear facility closure and decommissioning plans, radiological and non-radiological, environmental monitoring programs, nuclear facility operating procedures, and management of radioactive waste storage, processing, and disposal facilities. Mr. Jacoby was appointed by the Governor Perry to the Texas Radiation Advisory Board, of which he served as the chair for part of his membership. He is a member of the national and local chapters of the Health Physics Society and received the 2011 Richard S. Hodes Lecture Award for Innovation in Radioactive Waste Management. And with that, I would like to turn this over to Dr. Hamilton and Mr. Jacoby for their presentation, and there'll be a period for question and answers afterwards. Thank you.
Welcome, sir. Thank you, Mr. Mayor, and thank you, members of the City Council. I was going to say, after what you said to HEB this morning, maybe there should be 50 pounds less of Dr. Hamilton up here. After hearing what Ricky said kindly, I think maybe 50 pounds less of my resume. I guess PhD really does stand for piled higher and deeper. So with that, we were asked to speak on the radiation health and safety aspects of the proposed drinking water treatment facility. Both myself and Mr. Jacoby, my colleague, have put together a few slides to put things in context. Specifically, I'll be speaking to radioactivity. For those members of the board that haven't heard this before, radioactivity and radiation is everywhere. We'll put health and safety in the context of radiation dose. And then Mr. Jacoby is going to speak to some of the design features of the proposed plant as well. I put this slide together for exactly what it says in that title. Radioactivity is present everywhere. The radioactivity we're talking about in drinking water, and make no mistake, it's in all drinking water, not just from the Hickory Aquifer. It's in the water we're drinking now. It is natural in origin. It comes from Mother Nature. Like you can see here on the slide, we're getting irradiated all the time from radiation coming in from outer space, the atmosphere, coming out of the soil. It's in the food we eat because the food we eat grows in the ground, which is radioactive. It's in the water we drink, the air we breathe. This table out to the side here puts it in perspective. This is based on a National Council Radiation Protection and Measurement report, and it's not important that you understand what millirem per year is, that little esoteric unit up there. Think about when you take a Tylenol tablet. The doctor prescribes Tylenol to you that says take a tablet or two or take 200 milligrams, whatever. That's just a unit of dose. Everything in radiation comes down to dose. So you can see here that we do get exposed, every one of us just living and breathing on planet Earth, to low levels of radiation and radioactivity every year. I will point out that radon, it is averaged across the whole U.S. You guys are lucky, like we are in most places in Texas. We're not getting the radon exposure here in San Angelo. It's very trace because of the nature of the soils we have here.
So if I'm eating that steak that's got radioactivity in it,
yes, sir.
Cow that's sitting there.
Yes. The question was, when we eat the steak, it has radioactivity in it. Yes, you have trace amounts of radioactivity in the steak that you eat, in the plants that we, the carrots, whatever. But again, it's natural in origin. Okay, it's
Ms.
not
Mayor?
because somebody laced it with it.
Yeah.
Radioactivity is in many common things. That's what I want to point out here. You see here everything from drinking water to cow's milk. There are trace amounts of radioactivity. I picked these things because they're in picocuries per liter. That's a unit I've heard you guys speak to before. Everybody understands that's just the amount of radioactive something. In this case, the something in drinking water. And you can see here we've even put like what the treatment process would knock the drinking water down to. If you look at this next slide, same thing. These are things that are all common to you. That's not picocuries per liter, it's picocuries per gram. That is still just the amount of radioactive something that's in this material. Instead of it being the liquid, it's a solid. We have radioactivity in gypsum wallboard, bananas. For anybody that's been on campouts, those thorium lantern mantles, they're hard to come by now. You got to buy them on eBay, nerds like me, because everybody's bought them up because they are so radioactive. And again, the soil, radioactive, therefore our skeletons incorporate these radioactive materials into them. With that being said, I did want to ask Mr. Jacoby to come up here. He has picked out some sources that are common. This is a salt shaker. What gives it its orange color, just like where you get your yellow and gold colors in cosmetics, say like lipsticks, is it's been colored with uranium. We picked that because these are, again, natural radioactive sources that the public's being exposed to in their drinking water supply, so we wanted a source of natural radiation here. And we also picked this half-inch steel plate, if the council can see it. This is how thick the vessel walls would be in the vessels in this proposed plant, and I wanted to demonstrate just what a good shield a half an inch of steel is for these natural occurrences. Now this is emitting alpha rays, beta rays, and gamma rays, and X-rays, as a matter of fact. And you can see here, you can get quite a lot of counts off of it. Closer you get, the higher the dose. Like anything else, you get behind the steel, and you can see here as he passes, right, the dose rate drops to background. You're always going to get a few random clicks, and again, that's because these solar rays we talked about, the gamma rays coming out of the stones behind you, out of the gypsum wallboard, the concrete aggregate, things like that. All right, there are other natural sources Mr. Jacoby could demonstrate as well. No salt, the salt substitute that we all buy at the health food stores. We have potassium in it. Part of the potassium is naturally occurring potassium-40. So again, stopped by the steel. Granite the same way. It has all the same nuclides in it that we're talking about in the soils and in the drinking waters. And again, it is stopped by the steel. Mr. Jacoby also has some uranium colored marbles. And again, they emit the entire range of particles and rays that would be in the collected media. And again, it's stopped by the steel. So we had another demonstration we could show you with the cinder blocks, but the same thing. There's already nothing once we get beyond the steel except for the random counts. If we put the cinder block in the way as well, and the reason I make this point is because you'd have to go through several layers of concrete to get outside too. There had been concerns raised about members of the public happening by the water treatment facility. Again, you see we're just at background. Thank you, Mr. Jacoby. And so here are some dose calculations that I put together to put everything in perspective. You can see here people are probably familiar with having pelvic or abdominal CT scans or even nuclear stress tests. Those are the doses that you would get from those medical procedures in a matter of seconds to hours. If you look at what Mother Nature gives you down there at the 300 level, that's the dose that we get average across the U.S. population, like I said before, over an entire year. You can even see here what a mammogram, a screening mammogram with 4 images will give to a woman in, again, just a matter of minutes. The dose to the staff, and again, I will point out these are very highly conservative dose calculations I did. I assumed that the vessels were completely full to the point of needing to be changed out all the time year-round, and that all the radioactivity was up against the vessel walls. So if a worker had to work near them, it was as close to the worker as they could get. And then even rounding up from there, you can see that I only have 30 millirem per year. In other words, 1/10 of what Mother Nature would give them. And I, as an expert, don't actually think they'll ever get doses near that high. For the people that would happen by the facility, I didn't even put the dose up there because it wouldn't show up. It would be so small. So that is, again, to just kind of put things in context based on this treatment facility. And Mr. Jacoby, I'd like to ask him to come up here to speak to some more things about plant features specifically.
Mayor, Council, I'm Rick Jacoby. I was here a couple of years ago to speak to some of these same issues. And today I wanted to come back and address some of the issues that have been raised by Council with regard to the design of this and operation of this facility. This is a plan view of the facility itself, showing the exterior walls and then the equipment inside the facility. The ion exchange vessels are colored blue in this illustration. And I wanted to just point out some of the safety features that have been incorporated into this design. One is the masonry walls on the exterior of the building. They provide shielding, just as we were illustrating with this, this concrete block here. This concrete block is about 6 inches thick. The walls on this treatment plant are about 12 inches thick. So they're twice the thickness of this concrete block right here. There's containment sumps underneath the ion exchange vessels. These sumps are designed to capture a spill from a ion exchange vessel should it rupture. And if it were to rupture, the ion exchange zeolites would flow to those containment sumps where they'd be captured. And then if necessary, they could be recovered and shipped for disposal. The floors of the building are sloped to the containment sumps. We have epoxy coated the floors so that whatever falls on the floors can easily be swept or washed into the containment sumps where they can be recovered and then sent for disposal. These containment vessels, these blue vessels, and I purposely colored this shield that we used a moment ago. Pretty heavy. I worry that I'm going to crush your furniture here. This is a 1/2 inch of steel, and these vessels are a 1/2 inch of steel. Just wanted to illustrate for you how robust these containers are. It's not likely that they would ever fail. It's as we illustrated, there's not much radiation that can get through that much steel. The building has limited access. Only employees of the city and employees of WRT will be allowed access to the building to work on the equipment and the ion exchange vessels in this building. The building is monitored for any radiation exposure, as are employees, and small amounts of radon. Dr. Hamilton was mentioning radon gas, which is natural in the environment, will also be natural in these vessels, and it will be vented through the roof of the building into the atmosphere where it will be diluted and won't even be detectable. Very small amounts. There's been some concerns that the plant could possibly explode or catch fire and burn down. That's just simply not possible with this particular plant. This plant is very safe. There's no explosives. There's no flammables in the building. There's obviously water. We're flowing water through the building. There's the air in the building. There's some anthracite that are in the filtration vessels, but they're in a container where they couldn't possibly catch fire. Zeolite is a clay-like substance. It's not flammable, nor is radium. None of these materials are flammable or explosive, and so an explosion or a fire is just not a real concern. There's also been some concerns expressed by the council that a pipe break could result in some sort of an environmental impact or impediment. We did some calculations to look at a variety of pipe breaks, and our calculations show that if the pipe were flowing 9 million gallons per day at its absolute maximum capacity, and it were to rupture just right in half so that the entire 9 million gallons is discharged every day, it would take 2.3 years for that amount of water to flow into the nearest stream or arroyo or river and to elevate the radiation levels above the regulatory limits. And I think it's not likely that if you had a 9 million gallon a day break that it would flow for 2.3 years before somebody would do something about it. I suspect it would be taken care of within just a few hours or minutes even. Likewise, if you had a 9 million gallon a day flow, pipe break, rupture, and the water was flowing out onto the soil, it would have to flow for 240 days before the soil would capture enough radium to exceed the EPA's and the TCEQ's regulatory limits for contaminants in soil. As to livestock, our calculations would just indicate that a cow could not drink enough water or eat enough grass before it was taken to be butchered, to where it could have enough radioactivity in its muscle or tissue or bone to be a health hazard to anyone. So a pipe break is not, I think, a concern. There's been some concern expressed about storage of the radioactive materials in the city of San Angelo or at the plant. And there's just simply no long-term liability or storage concerns for the city, because your contract with WRT says they are responsible for the zeolite resins. They have to provide the resins. They have to take the discharged resins away, and they're not going to be storing them in the city, and the city has no liability for it. The resins will be discharged from these vessels. It'll be taken to a licensed low-level waste disposal site somewhere elsewhere other than the city of San Angelo. So in summary, as Dr. Hamilton said, radioactivity is present everywhere. The radiation doses from the environment and from this plant are minimal. The groundwater treatment plant, as I just illustrated, has been designed for safety, and there is no long-term storage or liability issues for the city because WRT is contractually bound to haul those wastes away. Dr. Hamilton, I'd be glad to answer questions if you have any.
Council?
I have one.
Yes, Johnny.
Mr. Jacoby, how many of these water treatment plants are there in the state of Texas, just off the top of your head, and have there been any issues, any pipe breaks, anything having to do with the water treatment plants? Do you have any idea how many are in Texas?
I don't know how many are in Texas. There's a number around the United States, and there has been no issues. I don't know that there's been pipe breaks. That's not to say there haven't been any, but I certainly don't know of any if there have been any pipe breaks.
Mr. Hamilton, do you have any idea?
Oh, no, I agree with what Rick said. I mean, we know that there's several of them throughout other states, and if there had been a pipe break, it's not for lack of looking or trying to find one. We would have, I think, found it. But I'm saying a major pipe break like this, I'm sure they have other, just the typical industrial issues and things like that.
So then the outer walls will be twice this thick?
Yes, sir.
Of the facility?
That's correct.
And by the way, that's not done for radiation shielding. That's just the structural nature of the building itself.
Okay. All right.
But it serves a dual purpose.
Sure. Thank you.
Don?
Gentlemen, I have heard some things like once the water flows through there for a specific length of time, the piping itself will become radioactive. Is there any?
The what will
the
become
piping itself that the water's running through will become radioactive?
You want to? I'm going to let Dr. Hamilton address that because that's one of his specialties, actually.
It's not the piping itself. There'll be a scale that could build up depending on the temperature and the pressure in the pipes. It doesn't happen uniformly through the pipes. It could happen at certain areas of the pipes. It would be easy to detect, and again, that would be from what I understand, pigged out annually. In other words, they would scour the scales off the inside. Now, most of the scale, I will point out, is not going to be radioactive anyway. It's almost like table salts, brines that form scales, but there will be trace amounts of radium in there. Again, very low level has been my experience, and where they have a lot of experience with that is the oil and gas industry. And again, they're used to handling that all the time.
Would it be such that we would have to move it to a disposal site, or would we be responsible for that, or WRT, or do you even know?
WRT would be responsible for that, is how I understand it, yes, sir.
Okay.
And again, that's not even necessarily something that would have to be moved to a special landfill. It would all depend on when the brines built up, did they have any radium in them, and to what level.
Gotcha. Okay. One of the other things you pretty well talked about all the breaks and those sort of things. We've heard that, for instance, in some of the outlying areas, that when they get ready to sell a water heater or something like that, it's radioactive enough that they can't do that. Is there any truth to that, or would we be in the same situation?
In some areas of Texas where the water is not treated, there is a buildup of radioactivity in water heaters. It's documented, it's in the literature. It is usually does not exceed the regulatory limits for the disposal of these water heaters in an ordinary landfill or in a junkyard or scrap steel plant or something. As a discretionary thing, some of these scrap steel companies will not take those water heaters because they just don't want the aggravation of dealing with them. But there's no health hazard, there's no regulatory prohibition on it. They could take them, and many do actually. One thing I want to go back and I would recommend you clarify this with your engineer, but it may be that WRT is not responsible for the raw water pipeline. I don't know for sure, but even if they're not, if you pig out that pipeline and you have a small amount of radioactivity, I believe the levels would be less than 30 picocuries per gram, right. In which case then you could just send it to an ordinary hazardous waste landfill or even a municipal landfill for that matter, if you should choose.
Are y'all familiar with the process that WRT uses?
Yes, sir.
From what I've read, they don't have a plant that is taking this much radiation out of the volume of water that we're looking at. Do y'all have any idea about the coming water that we have and feel good about being able to purify it?
Oh, I'm very confident. You know, this illustration here, they don't have a plant that has this many vessels, but they have many plants that have individual vessels the size of these that treat smaller amounts of water. So in water in and water out, we know that the water coming in and the water coming out is much safer and cleaner and meets all the health and regulatory limits for drinking water. So this is a proven process. The only thing that's bigger about this is you're moving millions of gallons a day as to some of the smaller plants that they have in Illinois, New Jersey, and Colorado, and other places.
Okay.
So it's the in and out that he's talking about. The volume would be the same per vessel, just more vessels. It's a scale-up question is what you're asking.
Right. Okay. Good deal. Thank you.
Yes.
That's all I have.
Any other questions from council? Any other questions from council? Do we have any questions from the public? Gentlemen?
Process is the cost of it.
Thank you very much. We appreciate that. We needed that, and that gives us some assurances. We appreciate you very much.